Good morning. This is Meteorologist James Longwith here with Dynamic Weather Agency LLC, and this is a severe weather update for the threat for strong to severe thunderstorms today across portions of Oklahoma, into North Texas this afternoon, and into the overnight, with all modes of severe weather possible today, including the threat for possibly some strong tornadoes. There's also the threat for severe weather across parts of the upper Mississippi Valley and the Great Lakes region, where there's also an isolated threat for winds and tornadoes in place today. And before I get into today's video, I do want to encourage you guys to hit that like button down below, subscribe to our channel if you haven't already. Helps out that YouTube algorithm and allows more people to find videos like this, along with getting the message about the threat for severe weather today across parts of Oklahoma and North Texas and up in the upper Mississippi Valley and Great Lakes region. Not only that, if you haven't already, head down to that description section and be sure to give us a follow on social media, and be sure to check out our Patreon page to help support this channel, and so I can continue to make weather related content like this, storm chasing videos, and maybe even post some new content for you guys, including some like how to do weather and how to forecast type videos here in the future. As I mentioned before in previous videos, I'm a full-time forecaster for the United States Air Force and a private consulting meteorologist for Dynamic Weather Agency. YouTube is just another side thing, and be able to show me your guys' support by giving me a comment, a like, a follow, things like that helps make me want to continue to make stuff like this in the future. Now, last but not least, be sure to check us out at dynamicweatheragency.com for more weather-related content and information that you can find on over there. Now, getting into today's video. Now, first, taking a look at the national radar this morning. For the most part, most of the conditions are quiet, clear, calm for the most part across much of the United States. We do have a low-pressure center over the Dakotas moving into Minnesota this morning. See some of that stratiform precipitation wrapping around that area of low pressure, moving through the Dakotas this morning. We have severe weather over parts of Minnesota and the upper Great Lakes and upper Mississippi Valley today. We do have a nice front stretching all the way from Chicago up through Kansas City, basically all the way into the northeastern portion of New Mexico. We'll take a look at that a little bit later as we take a look at the surface analysis. But basically we have this continuous front theory with this occluded low pressure center over the northern Great Plains, with this front stretching all the way across the United States, with a new area of low pressure developing across basically Colorado, Oklahoma, Texas later on this afternoon. We do have an area of low pressure spinning off the coast of the Carolinas. This is an area that we are monitoring for tropical development in our previous videos, but still low confidence for tropical development over the next 48 hours, probably around 20% according to the National Hurricane Center. That is bringing some gusty winds and a little bit of precipitation to the coast of the Carolinas, even moving into parts of the mid-Atlantic and the southern New England area. We have some precipitation moving on into that area. Now, zooming on into Oklahoma, again, conditions quiet for the most part this morning. We do have some precipitation over parts of western Oklahoma and northwestern Texas this morning. This is going to be with that low pressure system, and that front is going to be moving on in later on today. Now, taking a look at our current satellite imagery, this is taking a look at visible satellite imagery. The most notable thing that we want to take a look at this morning is basically where do we not have clouds. Over parts of central Oklahoma and the western central Oklahoma, we have some clearing in satellite imagery this morning, and this is going to be very important. We do have a strong cap on over the area that we'll take a look at a little bit later on in today's video, and this is going to help erode away that cap that we have on over the area. This is going to allow for intense surface heating on over the area, increasing low-level instability. That's going to be vital for severe weather development later on this afternoon and evening. Now, taking a look at our severe weather threat for today, taking a look at our day one convective outlook by the Storm Prediction Center, we do have that moderate risk for severe thunderstorms over portions of central and eastern Oklahoma today. We do have that threat of severe weather extending all the way up basically into parts of southwestern and even central Missouri, over much of western Arkansas, and even across parts of the southern plains today with that threat for severe weather. As we mentioned, all modes of severe weather is going to be possible today across much of that area. We do have a secondary threat for severe weather across parts of the upper Mississippi Valley and Great Lakes region, with a slight risk across parts of northern Minnesota today. Now, taking a closer look at Oklahoma, you can again see that moderate risk for severe weather across parts of central and eastern Oklahoma, including Oklahoma City and Tulsa. You can see that enhanced risk surrounding that, including areas like Fayetteville, Fort Smith, and even Dallas, Texas. Within that enhanced risk for severe weather in Springfield, Missouri, Texarkana are all within that slight risk for severe weather today. Now, taking a look at our tornado probabilities by the Storm Prediction Center, there's a 30% chance for tornadoes across, a 15% chance for tornadoes across much of central and eastern Oklahoma, with a 30% probability for large hail over parts of central Oklahoma today. And then here's that day one wind probability with, again, a 30% probability for damaging winds over much of central and eastern Oklahoma, and even to parts of northern Texas. Now, taking a look at our severe weather outlook graphic that we made this morning, taking a look at those areas in that darker red where we're expecting our tornadic thunderstorms to develop today. We expanded ours just a little bit further to the west and a little bit more north than the Storm Prediction Center's graphic for that basically 15% for tornadoes. We're seeing a few things that may indicate some storms may develop within that region and kind of parallel I-44 to the west of that region. So we'll have to kind of monitor that, but that would basically include places more like Elk City and Stillwater, and even parts of the northwestern portions of Oklahoma City may be more in the impact for tornadoes later on this afternoon and evening, and even into the overnight, with most places east of I-44 in the overnight hours. Now, taking a look at our severe weather outlook for central and eastern Oklahoma, as we mentioned, there is that moderate risk for severe thunderstorms today over that area. Probability for tornadoes is moderate, hail, moderate, wind, moderate. So we have moderate chance for all modes of severe weather today across that region. Now, as we take a look at our Futurecast radar, this is the NAM 3-kilometer solution that we're going to be taking a look at. As we move throughout the morning up to about 2, 3 o'clock, for the most part, central eastern Oklahoma, conditions are going to be quiet, clear for the most part, no rain or precipitation. By the time we move into about 6 o'clock, we'll start beginning to see thunderstorm development along I-44 in the I-44 corridor west of Oklahoma City. With explosive development, by the time we get to about 7 o'clock, you can see those thunderstorms beginning to develop and basically full maturity by the time we get to about 7 o'clock, slowly progressing its way eastward across the Oklahoma City metro around 9 o'clock. You can see by 10 o'clock it's moving basically east of Oklahoma City, continuing to follow that I-44 corridor, moving through eastern Oklahoma by the time we get towards midnight, and then eventually up into Arkansas as we move into about 3, 4 o'clock in the morning. It becomes more linear. The system begins to start to accelerate as it moves to the east. Now, taking a look at the HRRR, this is the high-resolution rapid refresh model that we have going on here. For the most part, for the NAM and the HRRR, most all the models are kind of in agreement. There's a little bit of differences on timing on very few things in the storm mode by the models, but for the most part, central and eastern Oklahoma is going to remain, rather clear, dry for the early afternoon and into the evening hours. Where we begin to see some of the differences, the NAM had thunderstorm development right around 6 o'clock. The HRRR has it more right around 6:30. We'll begin seeing thunderstorms development west of I-44 with some mature supercell thunderstorms. You see some of these isolated individual nature looks of these storms by 7 o'clock west and north of I-44. This is why I moved our tornado forecast just a little bit compared to the Storm Prediction Centers based off of just a little bit of things I've seen on the HRRR. But we'll still continue to monitor the NAM solution. But for the most part, most of these models are in pretty good agreement. You can see by the time we get to 8 o'clock, we have a nice supercell thunderstorm southwest of Oklahoma City. Continuing to move on to about 9 o'clock, we have more storm development to the south of I-40 with some more isolated supercell thunderstorms. Nice supercell again moving on through Oklahoma by 9 o'clock, according to the HRRR, with some more multicellular squall line type storms to the north of I-40 by the time we move into the 9 o'clock hour. As we move into about 10 o'clock, into 11. These storms more congeal into a single linear system, so now we have more of a QLCS, a quasi-linear convective system, squall line type thunderstorm, with some embedded supercells within this squall line thunderstorm. Again, like we said, we have that nice low-level wind shear and directional shear. It should support more supercellular type storms within this squall line, so we'll still see a tornado threat even past 10 o'clock. But I still think the greatest chance for tornadoes is going to be between 7 and basically 10 p.m. With a threat all the way out to about through some of the overnight hours due to basically that shear, but it's going to be less due to being more linear of a storm system as we move into 11. Same thing, the HRRR does pretty good with the timing, same almost about timing when the storm system will begin to move into basically western Arkansas in the morning around 3 o'clock in the morning and begin accelerating by the time we get in through that time as the storm system moves east. Now, taking a look at the surface analysis, it's actually a forecasted surface analysis by the Weather Prediction Center for 8 p.m. Eastern Daylight Time, 7 p.m. Central Daylight Time this evening. You can see that occluded low pressure system, the main low pressure system up in the northern plains, up in Minnesota, in the Great Lakes region, with that cold front stretching through Wisconsin, eastern Iowa, through Missouri, Oklahoma, down through Texas, with kind of a weak cold front, a secondary low pressure system developing along the Texas Oklahoma border. Now, as we take a look at some of our forecast models and the severe weather setup that we have for today, this is taking a look at the low level moisture. This is 2 meter AGL dew point. This is the forecast for 8 p.m. Eastern Daylight Time, 7 p.m. Central Daylight Time. We have southeasterly winds becoming more southerly across parts of the southern plains, transporting a lot of low-level tropical moisture from the Gulf of Mexico across Texas into Oklahoma. You can see those dew points in the basically mid to upper 60s, approaching 70 degrees, and I think this is underdoing some of that low-level moisture just a little bit here on the HRRR models. The NAM is doing a little bit more better, forecasting a little bit more moisture over this area, which is going to increase surface instability over this region. I think the HRRR model is just underdoing it just a little bit, but again, you can see this nice basically low-level moisture field moving on into the area. Dew points probably approaching 70 degrees by the time we get into the late evening, even into the overnight hours. A lot of humid, unstable, moist air mass that we have. And you can see that dry air moving on in from the west over parts of Texas, even into parts of southwestern Oklahoma along the dry line right here. That's going to provide upper level, that's going to provide surface forcing for thunderstorm development this evening. Now, taking a look at a SIN, this is basically what we call convective inhibition. This is basically what is inhibiting thunderstorm development. So basically think about basically a lid over a boiling pot of water. So once you remove that lid, all that steam is able to move upward and you have explosive development of thunderstorms. So this is what's limiting thunderstorm development. This is for 15Z, so basically 11 a.m. This morning, Eastern Daylight Time, 10 a.m. Central Daylight Time. And you can see we have a very strong cap over this area. And like I said on satellite imagery, we do have some of that clearing over Oklahoma. And that's going to allow for this cap to kind of erode away. It's going to increase surface heating on over the area, increasing low-level lapse rates by steepening those, allowing for a lot of turbulent mixing, which is going to help erode away this cap on over the region. Now, taking a look at our forecasted instability, this is looking at most unstable CAPE over the area. CAPE is convective available potential energy. This is basically the amount of energy that's in the atmosphere for thunderstorms to feed off of. Basically, what this is showing that the environmental lapse rate of a parcel of air is much greater than the moist lapse rate, and indicating that there's cold air aloft and warm air at the surface, and that the warm air at the surface is going to rise freely due to that cooler surrounding environment. This is going to be enhanced later on today by that low-level moisture transport, warm air advection, shortwave movement on through the region, and that diurnal surface heating. Now, as we take a look at our 850 millibar forecast for today, you can see that low-level jet moving on through the area, 30-40 knot low-level winds, as indicated by our 850 millibar chart over parts of Oklahoma and even northern Texas as we move into this evening. As we move up in the atmosphere, taking a look at 500 millibars, you can see that 500 millibar jet axis, and we have that divergent flow. We have some diffluence, upper level diffluence. This is basically allowing for divergence aloft and exhaust in the mid levels of the atmosphere. And then as we take a look at our vorticity chart, we have a nice area PVA ahead of that shortwave trough axis moving on through the 500 millibar region. Basically what PVA is indicating is positive vorticity advection. So we have cyclonic spin in the atmosphere, upward vertical motion, and divergence aloft, enhancing upper level exhaust. This is everything we're looking for severe weather forecasting. As we move up even higher in the atmosphere, taking a look at our jet axis, we have the PFJ moving over across parts of the northern Pacific with a jet finger dipping down across the Rockies into the Central Plains and moving on up into the upper Mississippi Valley and the northern Great Plains in the the Great Lakes region, with the subtropical jet moving anticyclonically over the southern plains into basically the Tennessee Valley and exiting out of the southeast. This is creating a nice area of shared energy over the central and southern plains region, with a jet max moving on through the area. And basically, again, this is showing that diffluent flow of the jet axis, with this jet max moving on in, enhancing basically upper level divergence, providing exhaust for thunderstorms in this region. And as we take a look at the winds, we have southerly winds in the low levels becoming more southwesterly as we move on up into the atmosphere, becoming more westerly as we move up into the upper levels of our atmosphere, indicating that we have some nice directional shear in the atmosphere, along with that speed shear, with the wind speeds increasing with height, which we'll take a look at that a little bit more better as we take a look at our skew T's here in just a little bit. Now, taking a look at our 0 to 1 kilometer EHI index, this is basically showing us where the best surface-based instability could be, and this co-locates also some of that 0 to 1 kilometer shear. You can see that over here in central Oklahoma. This possibly can basically move a little bit further to the west, west of that I-44 corridor area. You can see that nice area of basically EHI, and this is probably where our greatest threat for tornadoes is going to be, and this co-locates with some of the STP values and the SRH values that we'll see here in just a little bit. So taking a look at that storm relative helicity at 0 to 1 kilometers. Storm relative helicity values basically ranging anywhere from 250 to 350 meters squared per second squared. Taking a look at my little cheat sheet right here. Basically values from 150 to 299 meters squared per second square basically indicates supercells with tornadoes are possible, and anything from 300 to 449 meters squared per second squared means supercells with the possibility for strong tornadoes are possible in an environment with that. So we do have, like I said, 250 to 350 meters squared per second squared of 0 to 1 kilometer storm relative helicity. So expect supercells with tornadoes and possibility for some strong tornadoes with some of those values approaching over 300 meters squared per second squared over this region. Now, taking a look at our surface-based cape and our crossover winds, taking a look at 500 millibars, 850 millibars, and our 10-meter winds. You can see our surface winds are coming from the southeast, becoming more southerly at 850 millibars, and southwesterly at 500 millibars. Again, showing that speed and directional shear good for tornadic environments. And again, you see that surface instability over the area. This is the HRRR surface-based cape. As you can see, the cape is a little bit weaker as indicated by the HRRR compared to the NAM that was shown a little bit earlier. Now, as we take a look at our significant tornado parameter, our STP values, STP values range anywhere from basically 2 to about 5 across the region, with a maximum of a 6.7 across parts of central Oklahoma. Again, any value over 1 is basically indicating the good possibility for tornadic development across this area. So we have values from 2 to 5 indicating a very good chance for tornado development. This is, again, around 8 p.m. Eastern Daylight Time, 7 p.m. Central Daylight Time this evening across central Oklahoma, and this could be this could develop a little bit earlier maybe around 5 to 6 p.m. if we have some early development, but most likely from 7 to 10 p.m. is when the primary threat for tornadoes is going to occur, with some nocturnal tornado threat past 10 p.m. But for the most part, I think the greatest threat for tornadoes today is going to be between 7 and 10 p.m. this evening. Now, taking a look at our maximum updraft helicity from 2 to 5 kilometers. This is basically showing the tracks, our paths based off of this model run of rotating thunderstorms showing their updraft. And you can see, according to the HRRR, which is why I moved our tornado forecast just a little bit more to the west of the I-44 corridor and a little bit more north, based off the HRRR, indicating some of these helicity tracks and those updraft tracks of some of those rotating thunderstorms and those supercells a little bit more north and west, according to the HRRR run, while the NAM is still maintaining more of that storm prediction center across more of central and eastern Oklahoma for those best rotating updraft tracks. Now, taking a look at our forecast sounding by the NAM, this is for a little bit later. This is around 3Z. You can see nice, moist, low levels, temperature 74, dew point 72, dew point oppression basically 2, so good relative humidities, and the low levels indicating a very saturated, moist environment. LCL heights are relatively low, which is really good for tornadic environments. Surface winds from the south, nice low level jet of 50 to 55 knots at 925 to 850 millibars, with the winds becoming more westerly as we move on up in the atmosphere. Again, nice elevated mixed layer, steepening the mid-level lapse rates. You see the parcel path from the LFC to the equilibrium level. All that area in between the white and the red is indicating area where the parcel is warmer than the surrounding environment, and the environmental temperature in the red indicating basically showing that area of Cape where that parcel is able to rise freely due to it being warmer than the surrounding environment. The surrounding environment is cooler. Now, taking a look at our severe weather indices, again, Cape from 2,500 to 3,500 joules per kilogram, indicating that we do have, again, a basically moderate to moderately unstable environment over the area. Lifted indices around -7. That's indicating that we have a very unstable environment, basically in the mid-levels. Like we said, those LCL heights, basically from 500 to 1,000 meters above the surface, so low LCL heights. That is basically in research, the lower the LCL heights, the better for tornadoes, tornado development. Precipitable water around 2 inches, around 1 3/4 of an inch, so 1 3/4 of an inch. Taking a look at our wind shear, our kinematics right here. You know, we have surface to 1 kilometer shear, 37 knots. We got that strong low-level jet moving on into the area, so we have very good, strong low-level shear and some directional low-level shear. Surface to 6 kilometers, 64 knots. Typically, we want to see around 35 to 40 knots, but we're at 64 knots. So again, basically going with that shear to Cape ratio, we do have a high shear to basically moderate unstable environment. Taking a look at some of those other severe weather indices, D Cape around 1,100 joules per kilogram. So we got very strong downdraft potential for basically damaging wind gusts. So there's our damaging wind gusts. 3 Cape is around 161 joules per kilogram. Our convective temperature is around 80 degrees Fahrenheit. We won't reach that convective temperature. This is going to be mostly synoptically forced rather than heating based thunderstorms, as in like your more garden variety thunderstorms that you have, which happen more in your high Cape, low shear environments. Those are your more pulse type thunderstorms. And speaking of this shear, why is shear important for thunderstorms? It helps actually tilt those thunderstorm updrafts. That's very important to giving that tilt of that updraft, because it allows for the precipitation to fall ahead of the storm, so that none of that rain-cooled air is choking off that updraft. So that's one important thing for these type of supercell thunderstorms. That's one of the characteristics, is having that tilted updraft and that rotating mesocyclone in those thunderstorms. Again, taking a look at just a few other these severe weather indices. Basically our STP is relatively high, around a 6 or 7 according to this NAM forecast. K values 42, totals 72, so indicating just basically a good probability for thunderstorm development. Not really for tornadoes. Those indices aren't really for that. Basically, a good thing we want to take a look at is sweat index, but that is not calculated, it looks like, on these forecast SQTs, because it takes both instability and wind shear to come up with basically probability for tornadoes. Now, as we take a look at our hodograph, we do have a nice curved hodograph with southerly winds approaching basically 50 to even 60 knots due to that basically that very strong low-level jet. That low-level jet is going to be moving on into the area with some of those, and you can see again here with those west-southwesterly strong mid-level winds, 60 to 70 knots in the mid-levels. Storm motion from the west-southwest to the east-northeast at about 40 knots, and our critical angle is around 67. We do have a little bit of curvature to our storm slinky, so that's pretty good. Again, this is a PDS tour sounding, and again, take a look at that effective layer STP around a 7. So we have good probabilities for tornadoes. EF2 plus across the area. Taking a look at these box and whisker plots. Excuse me. Now, taking a look at some severe weather safety tips. Be sure to bring a bicycle helmet and some shoes with you. Most tornado deaths are due to blunt force trauma, so having a helmet over your head will help increase your chances of survival in the event of a tornado. Same thing with having shoes. You're going to have a lot of glass and nails and stuff from a tornado due to the debris at the post-aftermath of a tornado if you do have a tornado. Be sure to bring some snacks and water and some pet food for your pets and something to occupy your children to keep them busy during the event while you're sheltering in place, and also some basic first aid items and some of your meds if you need some medical medicine for any conditions that you have. For tornadoes, stay away from windows. Do not open up windows and stuff like that too. That actually is a myth. It can actually blow off the roof of your house much easier if you actually keep your windows open. So stay away from windows though due to the glass. Go to the basement if you have a basement. If you don't, the interior-most room on the lowest floor of your house is going to be the best area for you to hide. If you're in a car, it's best to maybe abandon that car, lie down in a ditch. If you can, be sure to cover your head. If you do that, do not park under underpasses. 1, that's illegal. 2, that's impeding the flow of traffic for other people who are trying to get away. You could be potentially putting people by backing up the traffic in harm's way. And 3, if there is a tornado, that can increase the winds under the underpass due to funneling, making the winds possibly under the underpass stronger than the storm and the passing tornado. So that's another thing. If you're in a mobile home, try to leave that and seek a more sturdier structure. Same thing if you're outdoors. Also, know the risk, know the difference between what a watch is and what a warning is. Social sciences has basically indicated that a very large portion of the population does not know the difference between what a watch is and what a warning is. So a watch means there's conditions becoming favorable for the development of storms. This is like taking a little analogy. This is like getting all your ingredients ready to bake a cake. While a warning means that severe weather is occurring or imminent, this is when you finally have that product of a cake in front of you, and that you should be taking action now. So a watch, you should be prepared. A warning means you should be taking action. Again, I would like to thank you guys for checking out today's video. If you haven't already, be sure to hit that like button down below, subscribe to our channel. Be sure to follow us on social media and check us out at dynamicweatheragency.com, and be sure to visit our Patreon page to help support this channel. As I mentioned today, the greatest threat for severe weather is going to be over parts of central Oklahoma and north Texas this afternoon and evening. Tornadoes, some capable of significant EF2 plus damage, are possible today. Destructive hail and severe gusts are all possible according to the Storm Prediction Center. That's taken right from their Day 1 Convective Outlook today. I'm Meteorologist James Long signing off for today. I may go live later on today, so be on the lookout for that. You guys have a great and wonderful day, and be sure to stay weather aware.